All right, moving on to complex fractions. We are on lesson 5-7. And complex fractions get a little bit more stressful, but it's just like what we've been doing, so you are going to do a great job. I'm actually going to skip number 1. I would encourage you to learn how to put that in your calculator. But let's look at this. Notice that because of this plus sign right here and this plus sign right here, this is saying 1 over r to the third plus 1 over s to the third all over 1 over r plus 1 over s. So notice that we do need a common denominator for the top and for the bottom. So on the top, the common denominator would be r cubed and s cubed. You would need all of that. So what would I have to multiply r cubed by to get to r cubed s cubed? S cubed over s cubed. So when I multiply s cubed over s cubed, that's just multiplying by 1. And on the bottom, right, I have to go ahead and multiply s cubed by r cubed over r cubed. So on the top, I have s cubed plus r cubed all over r cubed minus s cubed. On the bottom, the common denominator is rs. I would have to multiply this by s over s, and this one by r over r. Again, I can multiply anything through by 1 and not change its value. It looks like on the top, I have s plus r. Now, remember when I divide by a fraction, I'm multiplying the reciprocals. This is literally saying s cubed plus r cubed over r cubed s cubed times rs over s plus r. So the first thing I notice is that this rs can cancel out with this r cubed s cubed. Now, one other thing I notice is that this is the factor of perfect cubes. So I'm going to take a minute and factor this. So the perfect cube of s cubed is s. The perfect cube of r cubed is r. So remember that this is going to be plus minus plus. And this is s and r. On the outsides, we're squaring them. And in the middle, we're throwing them together. And this is all over r squared, s squared. And remember, we are multiplying by, well, this is just 1 over s plus r. So I notice that s plus r can cancel with s plus r. And I think that's it. So my answer is s squared minus rs plus r squared all over r squared, s squared. Now, just a reminder, this s squared and this s squared cannot cancel. Okay, anytime you have it connecting with positive or negative, plus or minus, it cannot cancel. All right, moving on to some more complex fractions. Let's look at this one right here. Notice we have a very big vinculum. The vinculum is separating the top fractions from the bottom fractions, so I'm going to go ahead and draw that just like it is here. And on the top, between 1, x, and x plus 2, my common denominator will be x squared. I called that x plus 2. It's x squared. So I have to multiply this by x squared over x squared. I have to multiply this by x over x, and this one by nothing. So on the top, I have x squared plus 3x plus 2. I know you're already saying it's factorable. It will factor. All right, now over here, I'm going to do the bottom in a pink. So if I have 1, this is over 1, and x, my common denominator on the bottom will be x. So I have to multiply this by x over x, and nothing on the right side here, just by 1. So I have x plus 2 over x. Notice the large vinculum here. All right, so when I have this, let's kill 2 birds with 1 stone. you guys told me you saw that we could factor here. The factors of 2 that add up to be 3 are x plus 1, x plus 2 over x squared. And remember, when I divide, I'm multiplying by the reciprocal. Sometimes I like to show those little binomials together. All right, x plus 2 can cancel out. X and x squared just becomes x. So it looks like my answer is x plus 1 over x. So these complex fractions are very similar to what we've been doing. There's just a lot of work on the top, a lot of work on the bottom, and they come together pretty nicely.